Okay, what did you do last time? The Thomson done, and after Thomson, we did Thomson model, and also we did okay, properties of charge. No, what is this? Properties of charge. Anything else? Okay. What is the spelling? Double L. And that's it. These three things. Any doubt in these three things? No. Huh? First 2 weeks in this chapter very difficult to have any doubt. Everything is pretty straightforward. When we get to the modern model, because this is all history, when we get to the current model, that's where things will come. Okay. Chalo. What is next? Next is Rutherford's atomic model, which is incorrect thing to say. We'll talk about why. But anyhow, after, so before this last model we had was Thomson's model, which was at what time? What time? 1904. है ना? So this is very recent. So this guy was student of Thomson. And he continued his work. Now, so what he did was basically he took a, you know this experiment? You have studied this before? Wait. So what he did, what is the experiment? You take every alpha particle and you bombard it on what? A very thin gold foil. Okay, that's it. That's the setup. You take alpha particle and make a beam of that alpha particle, and through that beam you bombard on a very thin gold foil. And what do you see? What happens? What happens? The more this happens, right? This is what happens. So what can we first observe from this? What can we observe? And yes, correct, right? And the deflection is of what nature? Deflection is of what nature? Repulsive, right? It must be repulsive because we have alpha particle, right? Alpha particle is what positively charged. This must think whatever is repelling this thing, that must be of same charge, right? Can we deduce that from this? That those are the what is this? Okay. So these are the observations for this. What are the observations? Most of the alpha particle pass straight through the gold foil without any deviation. Small fraction of particle deviated through small angle. And 1 in 20,000 NCRT says one out of 18,000 basically, whatever, roughly 18,000, 20,000 particles go back. Okay. Right this much. Okay. First, let's actually, okay, right. Then we'll continue. So just draw the diagram a little bit by yourself, and the gold alpha particle bombarding the gold foil. Even if it is very rough, just write this setup. Don't have to make this elaborately, just write very simply. draw this one. Okay. Right. Okay. And now from each of these observation, we can make one conclusion. What is the conclusion we will make from the first one? Okay. So the Thomson model out of the question instantly. Yeah. Changes. Second, small fraction of particle deviated through a small angle. That means whatever charge is making this deviation is concentrated in a very small region. And again, this reinforces that that's some solid part somewhere in the middle amongst all this empty space, because once the particle strikes that thing, it has to come back. Clear? From these three observations, we can make three different conclusions. Okay? Okay. Okay. So now comes the nuclear model of atom. So generally this is called Rutherford model of atom, but actually Rutherford never gave this any model of atom. He just did the Rutherford Goldfein experiment, and he never talked. For example, he never talked about electrons. This nuclear model actually it is a combination of two things, Rutherford, and there is this forget his name, but there is this Japanese scientist. Uh, can't recall his name, but he was the one basically at the same time he was working, and he was proposing a nuclear model of the sorry, not nuclear, solar system type model of the atom. And when Rutherford's work came into picture, he took his idea, and he was the one who actually proposed Rutherford to propose this model. So Rutherford never actually talked about electron, but so that's why I don't call it a nuclear, not the Rutherford model of atom, but rather nuclear model of atom. Model is now very straightforward. There is a solid positively charged mass in the at the center of the atom, which is called nucleus, and nucleus has what? Huh? Protons and neutrons. No, this is in 1911. Neutrons we get in 1932. At this point, there are only protons in this, right? So you have a positive body which of small size, heavy mass at the center, which is positively charged, and there are electrons around it. Okay, and there are two balancing forces. One is centrifugal force, and one is electrostatic force balancing that, and the electron is rotating around the nucleus. So this is nuclear model of atom, or which is also known as the Rutherford model of atom. Clear? So you can draw this simply. I will draw it here again. This is positive, and there is electron here. So this is the model of atom that comes out of the Goldfein experiment. Positive charge and most of the mass of the atom was densely concentrated in extremely small region. That portion is called nucleus. Nucleus is surrounded by electrons that move around the nucleus with a very high speed in circular path called orbit. Right? So again, in this model we are talking about electrons, which Rutherford never talked about. Electrons and nucleus are held together by electrostatic force of attraction, and what is keeping it in motion is electrostatic force and centrifugal force. You understand centrifugal force? Done? Okay. So this is the stuff you already know, I think most of it. This is okay. Before that, we'll talk about size of atom. Then we'll talk about. There are three more points now, which you may or may not have seen. First is through this we also the work also included size of atom, size of nucleus, which came from distance of closest approach, and angle of deflection. So let's talk about these things one by one. First is size of atom. So for this, we take the element to take is aluminium, and you will understand why, because the density of this is 2.7 gram per ml, and what is the molar mass? 27 gram. And now if we have these two data, what can we get from this? We can get the radius of atom. You understand how? What is the molar volume? Achha, by the way, gram per ml, 1 ml in centimeter cube, what is the relationship? 1 ml is how many centimeter cube? 1. So this is basically what? Density is equal to mass upon volume. What kind of volume? This is molar volume. What is the mass? 27 gram. What is the density? So what is the molar volume? It is 10 centimeter cube. Now this 10 centimeter cube I can equate to what? 4 by 3 pi r cube into Avogadro. So this is 10 into 3 by 4. Where will pi go? By pi, right? No, 3 के साथ है, 4 के साथ, हाँ correct. Divide by n Avogadro is r cube. You put these values, you will get r approximately equal to 10 raised to the power minus 8 or r. Clear? Clear? Now the what else can we find in through the what else is there to find in this model of atom? Atomic size we found. What else can we find out? We can find out the size of the nucleus. How do we go about that? How do we go about that? Any idea? Hmm? Exactly, right? If by what are you doing? Not only close. Basically, we have to observe very simply. Yeah, we just have to look at this one, right? If I can find this at the moment of collision, then whatever the distance is, that is my approximately that will be the size of nucleus or the radius of nucleus, right? Correct. So that's the next thing we do. So size of not zero size of nucleus call is this distance of closest sector. What is this? So there is a alpha particle. Let's say this is nucleus. Although I should make the ultra size. This will come and strike this. So how do we go about this? So let's assume this is a head-on collision, direct striking, as I said, the one with strike. So what can we say? We can say total energy initial equal to total energy final, energy, law of conservation. What is total energy initial? Kinetic energy initial plus potential energy initial will be equal to kinetic energy final plus potential energy final. What is the potential energy initial? What is the potential energy initial? It will be 0. What is the kinetic energy? This particle has some energy. Let's say half m alpha v alpha square, or you can just write kinetic energy. Will be equal to what is the final kinetic energy? 0. What will be the final potential energy? K into 2e into ZE by R minimum. Sorry, not my bad. Sorry, no, sir. Correct. Now you got it. So what is R minimum? R minimum will be, I'll write it in simpler, so I can write it K 2k ZE square upon kinetic energy of alpha particle. Clear? And from this here, from here, what we can deduce? What can we deduce? We can say that R minimum is directly proportional to Z, inversely proportional to kinetic energy, or also you can say this is inversely proportional to velocity of alpha particle. Correct? Clear? Again, putting the value for constant and everything, you can find a simple direct formula. What is that by? Where did it come from? What is the potential energy formula? Due to by R square. What is Q1? Alpha particle. Alpha particle, how much charge? 2. So this 2e. What is this? A nucleus. What is the charge of a nucleus? How much? By atomic number, right? Correct. If you have lithium, you have 3 protons. If you have sodium, you have 11 proton. Right? What is the nuclear charge of sodium? 11Z. Sorry, 11E. Clear? Okay. So now using this, we found size of nucleus. What is the size of nucleus? Size of nucleus is calculated by this formula. R is equal to R naught A 1 by 3. What is A? Atomic mass, or you can also call it mass number. And this R naught value is a constant, which is 4 by 3 into 10 to the power minus 15 meter, or in centimeter we can write it 10 minus 13. So the rough size of a rough radius, so radius of atom is turning out to be approximately how much? 10 to the power 10 meters. Radius of nucleus is turning out to be how much? 10 to the power minus 15 meters. Can you guess how big of a difference that would be? Huh? Yeah, it's like a the for example, this is a volume yeah. 5 kilometer? No, not 5 kilometer. Meter. Huh? It will be 5 kilometers. The volume is basic. 10 to the power 5 meter. Okay. So in terms of actually radius is not the right way. Volume would be the better judge. So volume का experiment देखोगे, difference देखोगे, तो this is 10 to the power minus 27 to 10 to the power minus 42, right? 3 times. So the closest example I can give you is the comparison of football, the volume of a football, and the volume of the football field, basically. That's the closest example I can give. So that's what is happening in an atom. If your atom is the size of football field, the nucleus is a football. Yeah. Huh? A to the power 1 by 3, yes, sir. Yes. R is equal to R naught A to the power 1 by 3. You get it from that formula, putting values, constant values. You can also, instead of writing size of nucleus, you can also write this heading as approximate size of nucleus. You know? Okay. I'll give you questions. Before that, one last point we'll write in this. So we did size of atom, size of nucleus, and last is number of alpha particles at angle theta. Whatever, 6 point radius. Number of Okay. So overall, there are 6 things in this model related to this model. 3 theoretical points, 3 mathematical points. Okay. See some questions. What is the size of nucleus? 10 to the power minus. What will be observations on alpha particle if parting scattering experiment Thomson model is true? Hmm? Was true. Yeah. Right. Very simply, because if you have solid, you're gonna strike it. What is going to happen? You come back. It's about get deflected at some angle. When a gold sheet is bombarded with a beam of alpha particle, only a few of them get deflected, whereas most this is because the nucleus has much smaller volume than that of correct. Which one? वैसे तो this question is again because they consider it to be Rutherford model. This will also be not true. Although you again, no, actually this will be true because they said could not be derived, not directly given. So this can be derived from this. This तो orbit का तो there is no conversation only. Okay. Next. What would happen? Huh? What? Yes. Same question. I'll give you some numerical questions. sorry, no, just 2. Then, what is the answer? Hmm? That's not the answer I have. Yes, sir. Of course, everybody is getting a different value. No. What is your answer, ma'am? No, sir. इसमें क्या complicated है यार? It's direct. What do you have to do? With total energy is equal to total energy, right? Kinetic energy initial, or you can, if you remember the formula, you can apply the formula also. I have terrible memory, I can't remember anything. I will drive it. So initial kinetic energy is what? Kinetic energy. How the directive value दिया हुआ है ना? Yeah. So this will be what? 0. This will be 0. This will be kz alpha particle है ना? ze 2e by r. So r will be k 2kze square divided by kinetic energy. So how much is this? 2 k value is how much? What is the value? 9 into 10 is power 9. What is z? 79. What is e square? 1.6 into 10 raised to the power minus 19 raised to the power 2. How much is the kinetic energy? 2 mega electron volt. So what is that? 2 into 10 raised to the power 6 multiplied by 1.6 into 10 raised to the power minus 19, because you have to, this is an electron volt, you have to convert it to joules, to convert it to SI units. That's it. So this will get cancelled by this, 2 will get cancelled by 2, R will be 9 into 79 into 1.6 into 10 raised to the power minus 19 plus 9 and minus 6. That's your answer. Clear? What happened, bhai? Where did you go wrong? Okay. ये तो we wrote in the first class, no? We did. Oh, my bad. Sorry, my mistake then. Clear? So next question. Clear na? Okay, chalo. Next is find approximate radius of nucleus of nickel atom. Okay. Find approximate radius of nucleus of nickel atom. Mass number of nickel is 64. 64. 64. No, this is a direct formula based. You have to do absolutely nothing. Which formula? R is equal to R naught a to the power 1 by 3. What is this? 4 by 3 into 10 to the power minus 15, 13 centimeter, 15 meter. And A is what? 64 to the power 1 by 3. 64 you can write as what? Clear? Okay. So next question likho forward. Anybody has any doubt by? No? Okay. In an alpha particle scattering experiment, in an alpha particle scattering experiment, number of alpha particles scattered, number of alpha particle scattered at an angle of 90 degree is 200. Number of alpha particle scattered at 90 degree is 200. Find the number of alpha particle scattered at 180 degree. Then no. Hmm? This is the formula. This is the formula. Yeah. N theta, number of particles which are deflected at angle theta or scattered at angle theta is equal to 1 upon sine to the power 4 theta by 2. Always ask, my handwriting is terrible. Always ask. When in doubt, always ask me. This is sine to the power 4 theta by 2. Now try. Try. In the meantime, I'll write the next question. You guys try by. Whether you get an answer or not doesn't matter, but every question you should exhaust your brain, figure out some way to approach it. Next lecture. Okay, previous one, what is the answer? 50. Did you get it, sir? Ma'am? No? Sir? Sir? Excuse me. What is your name? I forget. Abhik. ABHIK. Did you get the answer? Huh? No? Okay, wait, first. Did you guys write the question? Wait, okay. Let me just solve. Okay, fix first you write this. I'm confused. Then? No. Percentage change. Sure. Hmm? That's not the answer I have. It will be incorrect. But that's not the answer I have. But the answer I have is not reliable. What is yours? Decreased by 56%. The answer I have is 55.56. What did you say? Increased by 125%. Hmm? Increase का तो देखो सवाल ही नहीं है because it's inversely proportional. है ना? If you're increasing it, definitely it is decreasing. चलो पहले practice वाला क्वेश्चन करते हैं. So first question was n at what 90. So n 90 upon n other one is what 120 180. So n 180, can I say this will be sine 4 180 by 2 divided by sine of 90 by 2 to the power 4. Correct? How much is this? Sine 90. What is sine 90? Sine 90 is 1. What is this value? Sine 45. Sine 45 is how much? 1 by root 2 raised to the power 4. So how much is that? 4. So we have the value. What value do we have? 90 is 200. So this is 200 by n of 180. This will be equal to 4. So n of 180 will be equal to 60. Clear? Clear, sir? Okay? चलो ये करो. Again. These questions again, you don't have to think much. Very direct. So let's give you same question. One more question. Right. Right. In alpha particle scattering experiment, distance of closest approaches are okay. Now the experiment is conducted with another metal which has atomic number 1.5 times. Which has atomic number 1.5 times and kinetic energy of the alpha particle is double. ठीक है. So find percentage change in distance of flow. So चलो भाई, wrong. 72 point? No. Is that the correct question? Velocity is double. Velocity is double, right? Sorry, kinetic energy is double. That's not the answer. बताओ भाई, done? Did you guys solve this? Hmm? Okay. Sir, 66. Did you get it? Okay. So what are they saying in an alpha particle experiment? Distance of closest approaches are, this is given to us, okay? Now they're saying if the velocity of the alpha particle is increased by 50%. So let's say the velocity here was v, now the velocity is 1.5 v. So if the kinetic energy for velocity v was ke, this will be how much? This will be how much? What will be the kinetic energy? It will be 9 by 4. Let's say ke is, can I say that? Yes or no? Yes or no, bhai? Are, what is what is kinetic energy, bhai? Half mv square. Okay. So kinetic energy initial, if we say this is the initial value we are taking, this is v. Now what have we done? Alpha particle is still alpha particle, mass is still the same. So this is half into m, and this velocity is how much? Increased by 50%. So if this was v, now this is what? 1 by 0.5 times v. So this is what? 3 by 2 v square, right? Clear? This will be how much? So I can say kinetic energy 2 is half m v square by 9 by 4. So can I say that kinetic energy 2 is 9 by 4 times kinetic energy 1? And now you can solve that. You want me to solve it? You will do it? Ma'am, sir, you understand this? Yes or no? Yeah, I'm not getting. Okay. You have to say, yaar, hai na? Dekho, I know a lot of things, but one thing I don't have the ability to is read minds. I wish I had it, but I don't. So you have to express yourself for me to understand what is happening. So from this you can find the new R, and then just R2 minus R1 by, or R, actually R1 minus R2 by 100, है ना? Because this will be lesser. R is inversely proportional to V. We have increased, kinetic energy we have increased, R will decrease. Or you can take mod, whatever. You, you know mod, right? You know mod? No? Modulus in mathematics when you study, this is like a function. You put anything under it, it becomes positive. So minus 3 mod becomes plus 3. Yeah. So anytime we just want the magnitude in the sign is not relevant to us, we use that. Anyhow, this is clear. What is the answer for the second one? You get, huh? 25%. Correct. Okay. Done. You'll solve it after this, right? Ma'am, you'll solve this from here? Okay. What? What is this? This is not right. Ah, गड़बड़ हो गया. Now, the last part of this topic, drawbacks. So what is the drawback? The biggest drawback is that Rutherford, the nuclear model of atom cannot explain the stability of the atom. So there was this guy named Maxwell. What did Maxwell say? Maxwell said, if a charged particle is moving, your charged particle is under acceleration, it will do what? It will emit electromagnetic radiation. Okay. If there is any charged particle and that charged particle is under acceleration, that charged particle, acceleration, you understand? Acceleration is rate of change of velocity. You know? So it's a vector quantity, scalar vector, you understand? Scalar is a quantity which is only concerned with magnitude. Vector is a quantity which is concerned with magnitude as well as direction, right? Okay. What was I saying? I forgot. What was I talking about? Maxwell. So Maxwell said कि भाई, if there is a charged particle, that charged particle is under acceleration, then it must emit some electromagnetic radiation. What electromagnetic radiation means? Some electric field it will radiate, some magnetic field it will radiate. So if you are radiating electric and magnetic field, you are losing energy, right? Everything is energy. So if you are constantly losing energy, then the electron must spiral down, collide into nucleus, and the stability of atom should be like 10 to the power minus 5, 10 to the minus 6 seconds. We know that is not true, right? So we will say this is a failure of Rutherford model. Atom is stable, we know, but it is not able to explain that phenomenon, not adding up. Clear? So this was not according to the classic theory of electromagnetism proposed by Maxwell. According to the theory, every accelerating. Okay. By the way, some people say, okay, the electron is in constant velocity though. How is that acceleration? We will derive these values through Bohr model. How can this electron be in acceleration when it has constant velocity? Because this what is the direction? It is tangential, right? Circular motion, even the magnitude of the velocity is same, the direction is changing at all times. If the direction is changing at all times, then velocity is not constant, it is actually changing at all times. If velocity is changing at all times, then you have a direction. Clear? So that is the biggest drawback, and then other drawbacks are there which we will understand later. Unless you already know, you know spectrum of hydrogen atom, what is it? You know how we know that sun has hydrogen gas inside of it? Huh? Through this hydrogen spectrum we know that. That's how we know that. Yes, correct. So these are like the spectrums are like DNA of elements. They are like whatever the plate you will get of radiation plate, whatever photograph you can do, that is like a DNA of it. It's unique to that given element. We will talk about this if you don't know about this. There's a whole segment about spectrum of hydrogen atom and different atoms. But yeah, it could not explain the spectrum of hydrogen atom. And this is something basically what we do is, I'll tell you some rough idea, again we'll do it later. Basically spectrum is, we take like a gas in a tube, very highly, give it a lot of electrical energy, starts to emit white light. That white light we pass through prism, and whatever the result of that is, we take a photograph of that on a photographic plate, and that we call spectrum. And whatever is the outcome on the photographic plate, it's unique for every atom that you take. So why is that happening? This model of atom could not explain that. That is it. And last point, it says nothing about the electronic structure of atom, how the electrons are distributed around the nucleus, and where are the what are the energies of these electrons. Okay. Again, this is something we will deal with in Bohr's model, which is the next model which corrected these things. But something fundamental it got right about the atom, so much so that even today when you see any atom card representation, this is the representation you will get. The core idea, it's like Mendeleev. No? Now, everything else is just improvement, but the foundation of modern today's atom comes from this only, right? Still we are talking about there's a nucleus in the center, the electrons around it. That part is 100% completely true. Just to summarize, this was Rutherford gold foil experiment which led to which model? The nuclear model of atom, which says there is a nucleus at the center and there are electron around it, right? And the electron and the nucleus are held together by electrostatic force. Rest of the atom is empty, nucleus is very, very small. Now we can from that find out what is the relative size of the atom, which is about how much? 1 angstrom, 10 to the power minus 10 meter, right? And from that we can also calculate the size of nucleus roughly from distance of closest approach, which is how much? Roughly 10 raised to the power minus 15 meters, right? For any given atom for which we know the atomic mass, we can also find the radius of the nucleus by r is equal to r naught a to the power 1 by 3, where r naught is 4 pi 3 into 10 raised to the power minus 15 meter. And we can find n theta, which is number of particles scattered at angle theta, which is inverse of sine raised to the power 4 theta by 2, right? That's the whole. And now these are the drawbacks. That's literally what we did entire class. Anybody, any issue? No? Okay. Now next bit is we still have some time. Okay, you can do it. Done. This is done, right? Next is, so you have an element X. This you already know. This is Z. This is A. This is Z is what? Atomic number, which is equal to what? Number of electrons, protons, and this is equal to, sorry, this is what? Atomic mass or mass number, and this is equal to number of proton plus number of neutron. Now, by that's not fair. You are neglecting electron, all chemical reaction, all entire chemistry. We will be just dealing with electrons only. We never talk about the nucleus. But now we are not considering the electron in mass. How unfair? Why? That's not that. Huh? Negligible, है ना? Yeah. Correct, bhai. Matlab, this is one again. If an proton or a neutron is about 1.8 kg, then electron is 1 gram. And in mathematics, at least in chemistry, in front of 100, 1 is negligible. So 1% you can always ignore, and anything above 1, below 1% to 100% ignore. So, poor electron got neglected. Cruel world, what to do? Clear? Okay. Now, there, if you have two or not two species or a set of species, you can find based on these number of subatomic particle, you can figure out a relationship between them. Hai na? What relationships exist between them? Okay, let's talk about this also. So, before going to that, let's talk about average atomic mass. So, what is average atomic mass? ये तो लेकिन आइसोटोप की बात है ना, पहले वही करता है. So, first of them is what? Isotope. What is isotope? What is isotope? Same Z, different. So, example can be C6, 6C12, 6C14. Acha, what another way to say this would be what? Same number of what? Proton, different number of clear. Another example I can take is 1H1, 1H2, 1H3, or you can write this D, you can write this T. So H, D, T, number of neutron, number of proton. How many number of proton in all three? 1, 1, 1. How much neutrons? 0, 1, 2. Clear? Done? Okay. I'll tell you one statement, which is generically true, not just here, everywhere. Sorry. What is the statement? Statement is that mass or atomic mass or A is responsible for physical properties and Z is responsible for chemical properties. Does that make sense? First of all, why? Because what is responsible for physical properties? The solid mass, right? So that is atomic mass. Why is that make sense? Why is atomic number or proton responsible for chemical properties? Electrons and all chemical properties, everything that we will do in chemistry in 11, 12, it has all to do with electrons, right? So if you have same number of electrons, you're more likely to have similar electronic properties, right? Or similar chemical properties. Okay. So now if I have two isotopes, what can we say about the chemical properties of these two isotopes? They will be similar, not same, but similar. But what will we say about the physical properties of these two? Different physical properties. Do you understand that? So with for isotopes, you can write what? Similar chemical properties, but different physical properties. Write that. Yeah. Next will be isobars. Isobars are what? Same mass number, but different atomic number. So if you have different atomic number, then the atoms must be of different atoms. Sorry, atom must be of different element. है Atom must be of different element. And if they are of different element and have same mass number, what can we say about these now? They will have, they will have similar physical properties, but they will have different chemical properties. You understand? And again, what is same between them now? P plus N is same. Okay. Four more relations like this. Isoster, isotone, isodiapher, isoelectronic, which we will talk about in the next. Now, you solve TPP2? Did you guys do TPP2? I forgot to do that. Okay, it's a great look at it. Okay, this copy order then.
Any doubts from the homework? Graph questions? Show me. क्या doubt है बोलो? This is exponential graph, no? Exponentially decaying graph we had seen in the last class. Those are, you can consider them as constant which is greater than 1. That's it. So see, like the main thing in this case will be if you are taking a and a omega. So if omega is greater than 1, that means a omega will be greater than a. Accordingly, you will be plotting your ellipse. Okay. So suppose if I talk about the standard equation of the ellipse, what was the standard equation? Tell me. This kind of a graph we had got, right? Where the intercept on y-axis and x-axis we had known. This is a, this is minus a, b and minus b, right? So if a is greater than b, then in that case you'll be getting a graph like this. I told you that a is the intercept on y-axis. So if intercept on the y-axis as seen by you is bigger, that means this a is greater than b. Okay. So over there you just have to eliminate looking at the value of omega. So omega is greater than 1, that means the value of a omega will be greater than value of a, which means that wherever a omega is the intercept, that has to be bigger than a. Okay. So using that you can rule out the possibilities here. I mean that omega is only for telling you about the size of the intercept on x and y axis. Anything else apart from that? Quadratic ka doubts? Quadratic and all those questions were done. No? Quadratic also, some questions were there, no, in the module. APGP, what about that? APGP I think will be the initial chapter in your mathematics. Like after your basic mathematics, they will be starting with sequence and series only. No, what will be the flow of the chapters in maths? I mean, in the very beginning, you will be getting to know about all those in great details. What's the flow of the chapter? Okay, fine. So calculus is something that we will cover first. Okay, we'll try to complete that. Small topics like logarithm, if required. Logarithm will come in basic maths, I guess. Log will come in basic maths. Okay, so I don't need to cover that part. And then APGP formulas are required, that I'll tell you at the end. 1 or 2 problems we can do later on. Okay. So we'll start with calculus. Okay. The idea of calculus. Write down. Give the heading as calculus. So the idea of calculus starts with limits actually. Okay. How many of you know about limits? Okay. So suppose if I have a function, let's say I'm taking a function here, f of x. Okay. And the value of f of x is given as x upon x. Okay. So now if I ask you, find f of 0, what will your answer be in this case? So fx is equal to x upon x and f of 0 is what I want to find out. What will be the value of this? Undefined, right? This will be something called as undefined value. So 0 upon 0 is something which is not defined. But what if I ask you what is the value of this f of 0 plus and 0 minus? What is the meaning of 0 plus and 0 minus, by the way? If I ask you about this f0 plus and f0 minus, will it still be undefined? Tell me. What do you mean by 0 plus and 0 minus, this notation? 0 plus means we are talking about a value which is very slightly greater than 0, right? It is of the order of 0.00001, something like that. Okay. So 0 plus means a value which is slightly greater than 0. Similarly, 0 minus will be a value which is slightly lesser than 0. Okay. It can be minus of 0.00001. Under that assumption, can we say that this function is defined? So in physics, we don't need to, like in most of the scenarios, you will be required to calculate limiting values. You are not required to calculate the exact values. Okay, going forward, even in kinematics chapter also, Newton's laws of motion also, you will come across the situations wherein you will be required to calculate the maximum value of force or minimum value of force so that the body starts moving. Something like that kind of a situation you'll be getting. Okay. So limiting value is something that is more important, especially from the physics perspective. Okay. We are mostly not inclined towards calculation of the exact values in most of the scenarios. Okay. So that's why the idea of limit is something which is very important to us while going forward for calculus. Okay. So what will be f of 0 plus and 0 minus, by the way, in this case? Tell me. 1. The value of f of 0 plus and 0 minus will become 1. So we call this as left hand limit towards 0. Okay. Sorry, right hand limit towards 0. And this will be calling it as left hand limit towards 0. That means you are approaching 0 from the left. On the number line, let's say 0 is the central point. Okay. You are approaching from the left. What is the meaning of that? From negative side, you are moving towards 0. Okay. So 0 minus in this case will be called as left hand limit, and 0 plus in this case will be called as right hand limit. Okay. Approaching towards 0 from left side and right side. Okay. Let us write this as left hand limit LHL. This is RHL. Okay. Take down these notations and all. Similarly, I can define a function like this actually. Like suppose if I'm asking you f of x is equal to x square minus 2 divided by x minus 2. Okay. And I want you to calculate limit x tending to 2 f of x. What will be the value of this function? Tell me. What will be f of 2 first? Tell me. Again, that will be an undefined quantity. No, x square minus 2 divided by x minus 2 is what I have written here. So 2 ka square, sorry, x square minus 4 I should be writing over here. So 2 ka square will be 4, 4 minus 4 will be equal to 0, 0 divided by 0 is what you are getting. If you are going for exact calculation of the value at x is equal to 2, right? But if I ask you this kind of a question, what can you do in this case? Tell me. The cancellation of term x minus 2 is only possible if we are excluding that value x is equal to minus 2, isn't it? Can I factorize it and write it as x minus 2 into x plus 2 whole divided by x minus 2? Can you do this calculation, this cancellation of these two terms if I am saying that the value of x is 2? You cannot do that, right? Let's say if I'm saying that you have to choose the value of x as 2 and then cancel these two. Will that be the correct mathematics? You cannot cancel those two terms. Unless this term and this term becomes a finite term, you cannot do that, right? So that these two terms will become finite only if we are talking about a value which is tending towards 2. Okay, we read this as tending towards 2. This is limit x tending towards 2. Okay. So when x is tending towards 2, in that case, this will be a finite quantity, this will be a finite quantity, and they will be like very close to each other. So in that case, we can say that cancellation is possible. And then finally, we'll be getting the answer as how much? These two will be getting cancelled out, we'll be getting the answer as 4. Okay. So limit x tending to 2 fx, where fx is given as x square minus 4 divided by x minus 2, will become equal to 4. Whereas if I ask you to calculate the value of f of 2, that will be undefined. Okay. So that's the difference between tending towards a value and the exact value that we are pointing at. Okay. Write it down, write on this example as well. What is the idea of continuity? Any one of you know about that? That means if left hand limit and right hand limit and the value of that function at that particular point becomes equal to each other, in that case we say that the function is continuous at that point. What do we mean by continuous physically by expressing it through a graph? Continuity of a graph, let's say continuity of a function I want to check at a particular point. Okay, this is a function dependency on x. Okay, So suppose if I'm asking you whether a function is continuous or not, let's say if I talk about this function only, whether this function is continuous or not. So what I'll be doing in this case, I'll be checking the left hand limit and right hand limit. What are the left hand limit and right hand limit at x is equal to 0? Tell me. I want to check whether this function, by language you have to focus on the language actually. Fx is equal to x by x. What I'm asking you to check is, check the continuity of this function at x is equal to 0. Continuity of this function at x is equal to 0. So tell me about right hand limit. In this case we got the value as 1. Left hand limit in this case came out to be 1 in this case. Okay, what about the value of the function at x is equal to 0 in this case? Is that defined? It's undefined, right? So only if left hand limit, right hand limit and the value of that function at that particular value where we want to check the continuity becomes equal to each other, we will say that the function is continuous, right? On this point, to check the continuity of a function, to check the continuity of a function, to check the continuity of a function at a particular value of, at a particular value, to check the continuity of a function at a particular value, we need to verify whether the value of that function at that point, whether the value of that function at that point becomes equal to, is equal to, whether the value of that function at that point is equal to the left hand limit and right hand limit. In short, what we can say here is, as per this example, f of 0 should be equal to what? F of 0 minus should be equal to f of 0 plus. Only under this situation, only if this condition gets satisfied, we will say that this function is continuous at x is equal to 0. Okay. Graphically, how we can represent that? Suppose if I have a graph like this, so you know that any function, any dependency y as a function of x can be actually plotted on a graph now. Just for the sake of example, in the last class we had seen multiple example of straight line, parabola and all. Okay, so let's suppose if I have a situation like this, this kind of a situation I have. Okay, or let me take it this way. This is y is equal to fx graph. Okay, what you did was you had y as a function of x. Any equation can be given to you. In order to plot the graph, what do? The first principle says that we have to put different values of x, and then based on that we'll be plotting all those values on the xy plane, and after that we'll be joining all those points in order to get the graph. Okay, that is the first principle of drawing any graph. So I have a graph like this. Can you check the continuity of this graph at, let's say, x is equal to x naught, whether this graph is continuous or not? I mean, see, function wise you have understood that, yeah, if an equation is given to me, class will not end today. Till 5 o'clock this is occupied. Huh? No, 1:30 till 1:30 the classes will be happening here, and post that this will be the study room for them. Okay. Fine. So I was talking about this function, right? Y is equal to fx. So we have plotted the graph, and after that, like what are we able to observe in this case? Tell me. At x is equal to x naught, let's say x naught minus h if I'm asking you. Or this is also called as f of x naught minus. Okay. H is a very small quantity. In calculus, we use this notation h, okay, to represent a very small quantity. So f of x naught minus h, sometimes they write, sometimes they can directly write it as f of x naught minus. Okay. So f of x naught minus, what about that? Is that a positive value or negative value? Tell me. This is a function which has been plotted in the xy plane. You are able to observe the graph, right? So if I ask you what is the value of this function at, let's say, x naught minus, so what's the value of that? Tell me. Tending towards infinity, no, negative infinity. So can I say that the value of this function at this particular value is equal to minus of infinity? Because this graph is asymptotic, it is tending towards infinity. As we are approaching towards x is equal to x naught, we can say that the value of function is tending towards minus infinity, okay? Similarly, if I ask you what is the value of this function at x naught plus h or x naught plus, what will be the value of this? Tell me. We can see that the value is asymptotic towards positive infinite. So we can say that the value is plus infinity. Now tell me, is the left hand limit and right hand limit itself is getting satisfied? So is this graph a continuous graph? So this is not a continuous graph. This will be a non-continuous graph, okay? Not continuous. Graphically, you can identify it like this. Okay, looking at the graph directly, you can actually tell that, yeah, there's a discontinuity clearly visible at x is equal to x naught, because we had to leave the pen from here, okay? Suppose you are drawing a graph and you are not releasing the pen from the paper. In that case, you can say that you have drawn a continuous graph. So while drawing this particular graph, you'll have to lift your pen, isn't it? You have drawn some part of it. After that, you are lifting your pen and then again drawing the other part of it, isn't it? So that kind of a graph will be calling it as non-continuous or not continuous graph, okay? What about this graph? Tell me. This is a symmetric graph that I have drawn, okay? Straight line. Tell me whether this function, whether this graph is continuous or not continuous. See, while drawing it anyway, you didn't have to lift the pen, right? So it's a continuous graph. What about x f of let's say 0 minus and 0 plus, if I'm asking you to calculate? What is the value of that? Tell me. Can I say that the value of y in both the cases, if I'm taking a very small value to the left and to the right of this 0, the value of y will be remaining same on both the sides since it is a symmetric graph. So that's the reason why. Okay. And this value is going to be very small. No, this is like y is equal to x graph and this will be y is equal to minus x graph. Okay. These two graphs, this particular graph is a combination of these two. Okay. So under this condition, we can say that both the values are coming out as h. What about f of 0? F of 0 is equal to 0. Shouldn't you say that the values are not getting satisfied? Because of that, it should be a non-continuous graph. Yes. H is almost tending towards 0, no? So you can actually assume it to be 0 only. Still, it is a continuous graph. Sharp edge does not mean that it is a non-continuous, okay? There's a sharp edge over here. So though you are able to see that, yeah, left hand limit and right hand limit is coming out to be h, and we are getting the value of f of 0 to be equal to 0, right? But actually this h itself is so small that you will be considering it as 0 only. So by that logic, I can say that all three are getting satisfied and this graph is a continuous graph, okay? Is that clear? Fine. So this was about continuity. Before entering into differentiation, we need to understand about continuity and especially the limits part, okay? So we'll be entering into differentiation now, and we'll try to introduce it using the concept of kinematics also. Here and there, we'll be introducing the idea of kinematics as well here, okay? Differentiation, write down the heading. So suppose if I have a situation wherein a particle is moving along x-axis, okay? Particle is moving along x direction, okay, with some speed. That speed can be variable, can be constant. So I'm giving you a situation wherein particle is moving along x direction, and what I have done is I have plotted a graph of position of the particle as a function of time. Okay, position of the particle as a function of time I'm going to draw here, and it looks like this. This is x, this is t. Okay, dependent variable in this case is position of the particle, independent variable in this case is time. Okay, as the time is progressing, the particle is moving in x direction. Okay, this is not the curve along which the particle is moving. Let me tell you that again. This is what we have done is we have mapped the position at different instant of time in xt plane, and after that joined all those points in order to get this graph. Okay, so at some time t is equal to t1, let's say the particle was located at x1. Okay, and at some time, let's say t is equal to t2, the particle was located at x2. Now if I join these 2 points with the help of a chord, if I join these 2 points with the help of a chord like this, and complete a triangle out of it. So what exactly are you able to see this tan theta as? What will you say the value of tan theta in this particular triangle? Tell me. What is tan theta? Perpendicular divided by base. What is the value of this perpendicular? Tell me. x2 minus x1. This is x2. Okay. x2 minus x1 divided by t2 minus t1. So can we write this as x2 minus x1 as delta x, and t2 minus t1 I am writing as delta t. Change in time, change in x. Okay. So what exactly this tan theta is representing? What other quantity you have seen as this tan theta? Slope of that line. That straight line is actually making same angle theta with respect to positive direction of x-axis in anti-clockwise direction. So tan of that angle is nothing but slope. Okay. So can I say this is slope of chord joining those 2 points. Acha, what else this quantity you are reading this as? Tell me. Delta x is change in position of the particle. x2 is the final position, x1 is the initial position. And what is delta t? Time taken to attain that position, right? So change in position divided by change in time, what you have studied? Speed, velocity of the particle. See, in one dimension motion, whether you call it as speed or velocity, doesn't matter unless the particle is changing its direction. So I'm saying that the particle is continuing to move in the same direction. Okay, so you can say that the particle speed will be given by this. Okay, so can I say slope of chord to xt graph will be giving you the value of speed, average speed. We call this as average speed because this change has happened in a finite duration of time, isn't it? So right on this point, the slope of secant 2, the slope of secant 2, secant or chord, same thing. Okay, the slope of secant 2 xt graph over a finite interval of time, tells us the average speed of the particle, tells us the average speed of the particle. Now in this particular situation, tell me, if I had made the time interval to be very, very small, tending towards 0, like the way we have discussed in limits. Okay, if I make this time interval delta t to be very, very small, what would have happened in this? Tell me, what will be the change in position in that case? If I make this delta t tending towards 0, that means the time interval which I am choosing is very, very small. What was the initial position of the particle? X1. Now the change in time that I am choosing, or the duration that I am choosing, is very, very small. So under that condition, can I say that the change in position is also going to be very small? Given that the body has a finite speed, usually bodies do have finite speed, right? So if the body is moving with a finite speed, the change in position is also going to be very small if I am choosing the duration to be very small. Okay. So can I say that delta x upon delta t limit delta t tending to 0? What is the meaning of this? Tell me. What will happen to change in t in this case? That is going to be very small, no? So if it is very small, the notation that we use for it is given by dt. Okay. Small change is referred as d of that function. Okay. Differential change. We call this as differential change. So very small change in time. That's the reason why delta t got converted into dt. So as you already mentioned that, yeah, if time duration is going to be very small, in that case, the change in position will also be very small given that the speed of the particle is finite. So by that logic, can I call this as dx? Change in position is also very small. That's why we are calling it as dx. Okay. So dx upon dt, what exactly we are getting? Limit of t tending to 0, delta x upon delta t. Okay. So suppose if I'm taking the duration to be very, very small, tending towards 0, what does this average speed convert into? Tell me. That means particularly we are talking about one instant. No, let's say t is equal to 1 second and you are talking about t is equal to 1.000000001 second. So will that duration you will be able to sense in that particular state? You will not be able to sense that, no, because that duration, change in that duration is very small, no, change in that time is very small. At t is equal to 1 second, you will directly say whatever is the average speed between t is equal to 1 second and 1.0000001 second. That average speed is nothing but the speed at t is equal to 1 second, isn't it? Correct. At t is equal to 1 second, the speed will be nothing but dx by dt at that point. Can I say that? Is that clear? So write down this point. So this quantity gives you what? By that logic, the instantaneous speed, we call this as instantaneous speed of the particle at, let's say, t1. Okay, because we were talking about t is equal to t1, no? We had selected our duration of time to be starting from t is equal to t1, t is equal to t1 to a very small quantity. Okay, so in that, whatever was the average speed, that is nothing but instantaneous speed as felt by you, because that duration you cannot actually sense. You will say that 1 second and 1.00001 second is like 1 second only. Okay, so at that instant you are recording this particular speed. Write down. So can I also say that using this logic, can I also say that instantaneous speed is nothing but average speed in a very small interval of time? Instantaneous speed is nothing but average speed in a very small interval of time. You can make a note of that as well. Instantaneous speed is nothing but the average speed of the body in a very small duration of time. So small that you cannot distinguish between the two different instants. Okay. Instantaneous speed is nothing but the average speed of the body in a very small duration of time at an instant. So small that we cannot sense between the initial and final time. So small that we cannot sense the difference between initial and final instant. Okay. Under that condition, do you understand this point that while we are going to make this triangle, like the way in this particular case we were talking about a finite duration of time, we got a bigger triangle and we could clearly see that, yeah, delta x upon delta t is what the slope of the straight line is. Okay. Now, in case if I am talking about a duration which is very small and very close to t1, can you say that it will be approximately tending towards a tangent? Tell me. The triangle is going to be very, very small, no? Microscopic triangle you are going to get at t is equal to t1, isn't it? Suppose if this x2 I had brought close to x1, what will be the size of, what will be happening to the size of the triangle? Triangle will go on diminishing, no? It will go on diminishing. Let's say if I'm saying that delta t is tending towards 0, like the way I've mentioned over here, if delta t is tending towards 0, that triangle will be converting into a microscopic triangle, no? Which you will not be able to see. And you will simply say that, yeah, this particular line is actually touching this graph at that particular point, t is equal to t1, isn't it? Can I say that? Are you able to understand this point or not? Let me take this as t1 and this was x1. Okay, so what did I tell you? Bring this x2 closer to x1, so close that you get a microscopic triangle over here. Okay, so finally this chord will be converting into a tangent. No, you will be feeling that there is a tangent drawn at that point t1, isn't it? Because that triangle is so small located at this point that you are not able to see that actually. Okay, so now tell me, if I ask you what is dx upon dt at t is equal to t1, what will be your answer? Tell me. Again, at least you are getting a triangle, no? Though it is a microscopic triangle, but still there is a triangle over there. So can we not say that the slope of the tangent is nothing but the value of dx by dt at that point? Delta x by delta t, what was that? Slope of chord. So now since you have approached this x2 towards x1 so close that you are not able to see that triangle, you can simply say that this delta x by delta t will be converting into dx by dt. So that dx by dt is nothing but slope of the, like the way over there we were using slope of chord, here it will be turning into slope of tangent at that point, isn't it? So can we say dx by dt at t is equal to t1 will be slope of tangent to xt graph at t is equal to t1. Make a note of this. Slope of chord was giving you what? The average speed between t1 and t2. And the slope of tangent at t is equal to t1 is giving you what? It is giving you the value of instantaneous speed at that point. T is equal to t1. So now the question is, if any function is given to you, position as a function of time is given to you, can you find out the instantaneous speed at different time instants? There has to be some mathematical operations that we need to know in order to calculate this value, no? Then only we can find out the value of instantaneous speed at different instant of time, right? So there comes your differentiation. We'll be talking about that. Write it down. Acha, x in this case is a function of t, right? X is a function of time in this case. So in general, for any graph, not just for position versus time graph, if any y versus x graph is given to you, if somebody asks you what is the slope of tangent at x is equal to x naught, what will you do? Simply you will find out dy by dx at that point. Okay. What is the meaning of this? I have written down the meaning of differentiation actually in graphical terms. This is called as geometrical meaning of differentiation. Okay. Geometrical meaning of derivative or differentiation says what? The slope of tangent to x versus t graph at t is equal to t1 can be calculated by finding out this function dx upon dt at that point. Okay. What is the method to calculate this? That we will see. But you can now understand that, yeah, if I have a graph given to me, slope of tangent, if I want to find out at a particular point, I'll simply calculate dx by dt at that point, and that will give me the answer. Okay. Right on that point as well. In general, for any function y is equal to fx, in general, for any function y is equal to fx, the slope of tangent to a point, the slope of tangent to the graph at a point, the slope of tangent to the graph at a point can be calculated by finding out the differentiation of y with respect to x, can be calculated by finding out the differentiation of y with respect to x at that point. Differentiation of y with respect to x at that point. Okay. Now, as we have already seen that, yeah, x was actually a function of time, right? Position was a function of time in this case, okay? So if I want to write down dx by dt, can I say that this is nothing but y2 minus y1 divided by, sorry, x2 minus x1 whole divided by t2 minus t1, where t2 is tending towards t1, okay? Can I say that? Because the interval is very small, that's the reason why we had started with this logic only, no? We had started with this idea, delta x by delta t is x2 minus x1 by t2 minus t1. And then we took this term as tending towards 0. Because of that, we wrote it this way, okay? So x2 minus x1, what is x2 in this case, tell me? Can I say this is nothing but x at t is equal to t2? And t2, can I call this as, let's say, t1 plus h, where h is tending towards 0, okay? Similarly, the second one, can we write this as x1 was, what was x1? The initial point. So under which condition do you write this quantity as dx by dt, tell me? If x2 is nearly tending towards x1 and t2 is nearly tending towards t1, right? Of course, this x2 has to be greater than x1, no? Somehow it has to be greater than x1. Similarly, t2 has to be greater than x1, because you cannot go back in time, no? You are starting from t1, so you have to go further, no? You cannot go back in time. So t2 has to be greater than t1. So that's the reason why we are saying that this x2 is, let's say, greater than x1 at that instant of time, okay? This divided by how much? H, right? T2 is going to be t plus h, and t1 is going to be t, let's say, for a general t I'm writing, okay? Now what is the value of h in this case, tell me? Tending towards 0. So this is called as the first principle of derivative, okay? Dx upon dt. So in general, if you want to find out the derivative of x with respect to t, this is the rule that you have to follow, okay? X of t plus h minus of x of t divided by h will give you the value of dx by dt, okay? Write it down. So just for the sake of example, let's say if I'm giving you a function like this, x is equal to t square. Can you find out the value of dx by dt in that case using this idea? X is equal to t square. Use this idea and find out the value of that. As per the definition, what should we do here? X of t plus h, right? What is x of t? T square, isn't it? X as a function of time is given to you. Know, at general time t, we can say that the value of x is t square, okay? So can I say x of t is t square? Using that logic, x of t plus h is going to be t plus h whole square. All you need to do is, wherever t is there, put that as t plus h and then get the function, required function. So take the difference of these two, divide it with h, see and what answer you are getting from here. So dx upon dt in this case is t plus h whole square minus t square whole divided by h, limit h tending to 0, okay? After expanding this, what exactly you are getting? T plus h whole square. Okay, can you directly put the value of h as 0 and get some answer here? If you put the value of h as 0, in that case you will be getting this as t square minus t square divided by h, which will be coming out as 0 by 0 once again, like the way we started, okay? So that's why h has a significance, like the way we had discussed earlier also in limits. So now if you expand this, what you are getting? Limit as tending to 0, t square plus 2th plus h square minus t square whole divided by h. This t square is getting cancelled out. Finally, what we are left with? 2t plus h, right? And what is h? Limit h tending to 0. So the final answer for this is coming out as 2t. Okay. So this is differentiation from first principle. Using the basic principle, we are deriving the value of derivative of t square with respect to t. So now, similarly, if I ask you to find out for t cube, what exactly, like, can we derive a relationship here? Let's say for t cube, if I ask you to do, you will be proceeding in the same manner using the first principle, t plus h ka whole cube minus t cube divided by h. Now if you evaluate that, you will be ending up getting the value as 3t square. Okay, so looking at 2 or 3 such higher power of this derivative, we come to a conclusion that if I have to find out the differentiation of t to the power of n with respect to t, this will be turning into nt to the power of n minus 1. Okay, note it down. Check whether this is getting satisfied for this equation or not. T square, power is 2, so can I write this as 2 times t to the power of 2 minus 1? That is coming out as 2t only, no? So for this formula, this is the result. Similarly, as you go ahead for the higher powers, you will be getting this kind of a relationship. Okay, we are not going to derive for that for the higher powers, but you need to accept this and then accordingly proceed right now. Is it clear to everyone? Should we go to the next slide? Fine. What do you think should be the derivative of a constant? Tell me. There are two ideas that I have told you. One is the physical use of that formula in order to arrive at the result. The other one is the graphical way. Okay. So either what you have to do is you draw this graph y is equal to c and see what is the slope of tangent for that particular graph. Okay. So y is equal to c, what kind of a graph you are going to get? Tell me. I mean, x is equal to c. Let's say x is equal to c is given to you. Okay. What kind of a graph you are going to get here, where this axis is x-axis and this axis is time axis? So tell me what kind of a graph you are going to get here. X is equal to c. I hope it is clear to everyone what kind of a graph we are going to get here. It will be somehow like this, no? This is a constant c. Okay. What is the slope of this straight line? It is throughout 0, no? Since this is a straight line, the slope has to be constant, and that constant is nothing but 0. So slope of the straight line in this case is 0. That's the reason why the other way around, using the geometrical meaning of dy by dx, the thing that I have told you. What did I tell you in geometrical meaning of dy by dx? Slope of tangent at a point will give you dy by dx at that point, right? So slope of tangent to this graph will give you the value of dc by dt, isn't it? The value of this is going to be how much? 0. So constant ka derivative is always 0, right on that point as well. So two ways of looking at the differentiation we have already seen. One is geometrical way, the other is physical way. Can we also say it gives you the rate of change of a function with respect to the other function? Let's say dx by dt, if I am saying. What was the definition of velocity, if you can remember? In your early classes, you have studied about that. No? Velocity is nothing but rate of change in position. We used to call it as rate of change in position, right? So rate of change in position, by that logic, should be dx upon dt only, isn't it? Because velocity, we could define it as dx upon dt. So whenever you are taking a rate of change in a quantity with respect to the other quantity, then also you can make use of derivative. Okay. What do you mean by dy by dx in terms of rate? The rate of change in y with respect to x. Okay. Right on this point as well. Derivative as a rate measure. Derivative as a rate measure. What is the meaning of derivative as a rate measure? Write down. Dy by dx means the rate of change in y, with respect to x. The rate of change in y with respect to x. Now when I define this idea, rate of change with respect to a particular variable, then you can write it this way, like the way I have told you already. Dy by dx is rate of change in y with respect to x. If I simply define rate of change in position, the definition of velocity was rate of change in position only, no? You didn't have to explicitly mention that, yeah, that changes with respect to time. Rate of change in position is velocity. So if simply rate of a quantity is given to you, what do you mean by that? You are taking the change with respect to time. Okay, right on that point as well. the rate of change in a quantity is always seen as the rate of change in a quantity is always seen as the change with respect to time. The change with respect to time. The change with respect to time. Okay? Right on the next point. The rate of change in the gradient of a quantity, the gradient of a quantity, the gradient of a quantity is seen as the gradient of a quantity is seen as change with respect to length. Change with respect to length. As you progress forward, we'll be entering into electrostatics where we will see the gradient of potential. Okay. So whenever you are talking about, like the way you define rate of a quantity as change with respect to time, in the same way gradient of a quantity is defined as the change with respect to length. Okay. Change with respect to position. Is that clear? Gradient of a quantity means change with respect to position. Okay. Gradient, divergence, all those things we will see at the later part of this basic maths topic. Okay. Fine. These are some standard derivatives which you have to remember. You can copy it down. You can actually prove it using basic principle also. Can you prove it? This function can you prove? Make use of the first principle and try to arrive at this result. F of x plus h minus f of x divided by h. Using that, you have to come at this result. Okay, since we have started with x versus t, so that's why you take it as sine t with respect to t. Okay, cos t with respect to t. Wherever x is there, just replace that with t. Because mainly in physics, you'll have to deal with change with respect to time. Okay, so wherever there's a x, just replace that with t and write down the formula. That means what you will be writing here, d of sine t with respect to dt, that will be equal to cos t. Okay, so in the same way, you have to write down the other formulas as well. I'll add one more here. A to the power of x, where a is a constant. Okay, done with first principle. Sin x का कर लिया. Make use of the first principle. दिखा दो उसको करके. कोई एक trigonometric function choose करके. Take sin x. This one. I'm talking about this. Make use of this and try to arrive at that result. फर्स्ट प्रिंसिपल का यूज करके साइन एक्स का डिफरेंशिएशन निकालो, साइन टी का डिफरेंशिएशन निकालो विद रिस्पेक्ट टू टी. d of sine x with respect to x. How can we write this as? Sine of x plus h minus sine of x, है ना, f of x plus h minus of f of x whole divided by h, limit h tending to 0. Now this is what we have to factorize now. क्या आ जाएगा ये? What is sine of a plus b formula? This we have already seen, no? Compound angle formula. Sine a cos b. So this will be sine x cos h plus sine h cos x minus of sine x whole divided by h, limit as tending to 0. Okay. Now what is cos h? Cos of very small angle. That approximation you had seen. Cos of very small angle. What was that? 1, no. Cos 0 is 1. So anything that is tending towards 0 will also be 1. Okay. So this quantity is equal to 1. By that logic, can we cancel this and this? So now what are we left with? Sine of h cos of x whole divided by h, where limit h is tending towards 0. Okay. Now tell me, for using small angle approximation, can we approximate sine theta as theta? Sine theta was equal to theta as per the small angle approximation. So can I cancel these two? So what value we are finally getting? Cos x. So derivative of sine x with respect to x is how much? Cos of x. Okay. Similarly, you can prove it for the other trigonometric function and logarithmic function also. Okay. Now as for the start, you can actually refer back to the formulas, because if you're not very used to differentiation, you'll have to refer back again and again while solving the problems. For now, maybe you can make use of those formulas, but while let's say you are solving, let's say around 30-40 questions, you'll remember all the formula, right? We'll see some basic rules, and then after that we'll go into the questions. Okay, write down first one, sum rule. ठीक है. Before going into this, let me define some parameters that I'm going to choose here. Alpha, beta, these I'm going to take as constants. Okay. Then u, I'm calling it as fx. V, I'm calling it as gx. What do you mean by fx and gx? They are different functions of x. Okay. Fine. So using all these assumptions, I'm going to write down these rules. So the first one is sum rule. D dx of alpha u plus minus beta v. Alpha u plus minus beta v. Write down. So whenever a constant is multiplied with a variable, whenever a constant is multiplied with a function, that constant can always be taken outside the differentiation. Okay. So what you'll be doing is you'll be separating these two first. D dx of alpha u plus minus d dx of beta v. Okay. In the next step, what you will be writing here is u times, sorry, a alpha times du by dx plus minus beta times dv by dx. So if you have a linear combination of two different functions wherein a constants are also multiplied to the variable, those constants can be taken outside the derivative, and you can make use of the distributive law for this derivative. Okay, write it down. Just for the sake of example, suppose if I have a function like this, 5x square plus 2x plus 1. I want to differentiate this function. I want to find out d of fx by dx. What will be the value of this? Treat this as u v some w, okay, and make use of the sum rule and find out the derivative. What is 5x square ka derivative? 5 will be taken outside the differentiation. X square ka differentiation with respect to x is how much? Just like t square ka differentiation with respect to t. Power is 2 n t to the power of n minus 1. That formula is applicable. So what value you will be getting here? 2 times x to the power of 2 minus 1 is 1, okay, plus x ka derivative will be how much? 1, isn't it? 1 x to the power 0, and constant ka derivative is already known to us, 0. So what's the final answer for this? 10x plus 2 is going to be dy by dx in this case, okay, fine. Tell me the derivative of this function. 5 to the power of x plus 6 log of x. Ln is, what do you mean by ln? Log with base e, okay. Ln is the notation for log with base e. So make use of this and find out the answer. Solve this question, tell me the answer. A power x, what was the derivative of that? A power x, what was the derivative? A power x ln a. So can we write this as 5 power x ln of 5? Correct? Now second one, 6 is a constant, can be taken outside the derivative. Ln of x with respect to x, what was the derivative? 1 by x. So we'll be getting this as 6 upon x. Correct? 6 is a constant taken outside. Ln x derivative is 1 by x. What about cot x? Minus cosecant square x, okay. So this is the use of sum rule, though pretty basic, but you need to understand about all these rules. The second one is, write down, product rule. Same assumption I'm going to take, okay, this one. Now derivative of let's say product of two functions. So how do we define this? We can write this as u into dv by dx plus v into du by dx. Of course, the proof of all these you will be studying in calculus, okay. Once you go across the calculus, you will be looking into all these proofs also. Write down. Let's say product of two functions is given to you. You can leave one function, differentiate the other function. Same way, the second one also you can do. Done. For example, let's say if I have a question like this, y is equal to e to the power of x sine of x. Okay, product of two functions are given. Tell me the answer for this. So dy by dx can also be written as this notation, okay, y dash we can write it. Once if you are differentiating y dash, 2 times if you are differentiating double dash, okay. So y dash will be equal to, this is nothing but dy by dx only. These are different notations that can be used, okay. Dy by dx can also be written as y dash. What is y dash here? Tell me. E power x I am leaving. Sin x ka derivative with respect to x is how much? Cos x. Then sin x I am leaving. And e power x, what was the derivative of that? Same e power x only, no? So finally we are getting the result as e power x sin of x plus cos of x, okay. Clear? Okay. Find out the derivative of this. There are three functions in this, right? U, V, W. What to do here? Two functions you will be leaving out, one of them you will be differentiating, okay? Let's say if you have product of three functions given to you, d dx of u, v, w, where all three are function of x. What you can do is uv into dw by dx plus uw into dv by dx plus vw into du by dx. Okay. What is y dash here? Tell me. E power x ln of x. I'm going to take outside first. Derivative of this function is how much? 2x plus 2 plus next one will be x square plus 2x minus 1 e power x ln of x. This time I have differentiated e power x, okay, plus e power x x square plus 2x minus 1. What is the derivative of ln of x? 1 by x, okay. So suppose if I ask you what is the slope of tangent to this graph at x is equal to 1, will you be able to find out the answer now? Slope of tangent to this function, this graph at x is equal to 1, how much is the value of that? You know that slope of tangent to a curve is given by dy by dx at that point, okay. Dy by dx you have already calculated, all you need to substitute is x is equal to 1 in this case, okay. So slope of tangent to this graph at x is equal to 1, what I'll do is y dash I have calculated, in place of x you will be putting 1 everywhere, okay. What value we are going to get? Is y dash 1, okay, because y dash is again a function of x, no. So y dash of x, in place of that y dash of 1 you are going to write, is going to be how much? E ln 1 is going to be 0. So first term that way will be 0 only. Second term is also 0. Last term is only remaining. So how much is the answer coming out here? This term is how much? 1 plus 2 minus 1. That means 2. E and 1. So 2e is the answer. Okay. Slope of tangent to this graph at x is equal to 1 is going to be this much. Okay. Fine. Write on the next rule. Quotient rule. So now we are interested in calculating d dx of u upon v. So this will be given as v into du by dx minus u into dv by dx whole divided by v square. Again u and v are function of x. Find the differentiation of this. What do you have to do here? V you will be leaving, U you will be differentiating first. Don't change the order. Okay, that matters here. Whereas in the last example, while we were doing the product rule, over there the order did not matter. You can leave any function, differentiate the other one. Here it will matter because there's a minus sign over here, okay, in between. So what's the derivative? Tell me. We have to leave. So x plus 1 I'm going to leave out. X square minus 2x plus 1, what's the derivative of that? 2x minus 2. 2x minus 2 is going to be the derivative. Then minus, now I'm going to leave out this function, differentiate this function. So if I'm going to leave out this one, then x square minus 2x plus 1, x plus 1 derivative is going to be 1, whole divided by x plus 1 whole square. Okay. So the final result for this is 2 times x square minus 1 minus of x square minus 2x plus 1 whole divided by x plus 1 whole square. You can factorize it and get the final result. Last one, usually the ones who are not aware about differentiation, they find it a little bit difficult. That is chain rule. Write down. It works on function of function. Okay. Okay, function of function, what is the meaning of that? Let's say if I have a function like this, cos of x square. So angle in this case is not dependent upon x, rather it is x square. Now x square in turn is dependent upon x. Okay. This function as a whole, you can actually take it as cos of t, let's say. So can I say by that logic, cos t is a function of t, and that t is actually a function of x again. So those kind of a function we'll be calling it as function of function. Okay, f of gx, something like that. Okay, because x square itself is a function of x, no? So whenever you have a function of function, that means d dx of f of gx is given to you. Okay, the simplest form I'm taking here. Okay, d dx of f of gx, like in this case your f is going to be cos. Okay, what is gx in this case? X square. So cos function is a function of x square, and x square is in turn a function of x. Okay, so under these conditions what you'll be doing here is you'll be writing this as f of derivative is going to be f dash of g of x multiplied by g dash of x. Write it down. Try to understand what I have written here. F dash of g of x multiplied by g dash of x. What is the meaning of this? That means f of gx, first you are differentiating with respect to gx, and then in turn gx is differentiated with respect to x. Okay, let me write down the meaning of this. What is the meaning of this? D of f of g of x, first you will be differentiating with respect to gx, and then gx will be differentiated with respect to x. Okay. So finally, what is the result coming out? Tell me. What we have done is simply multiplied and divided with this quantity. No? Finally, you are going to get this result only, d of f of gx divided by dx. But direct differentiation is not possible. That's the reason why we are choosing an alternate path. Okay. Like for example, suppose if I want to solve this one, what do I do here? Tell me. Go with this rule and tell me the answer for this. F dash of gx. That means cos x square, you will be differentiating first with respect to x square, and then x square will be differentiated with respect to x. So you can write this as cos of x square derivative with respect to x square, and then x square in turn will be differentiated with respect to x. So final result for this is going to be 2x. What is cos t with respect to t? Tell me. Sin t minus sin t, isn't it? So cos of x square when differentiated with respect to x square is going to be how much? Minus of sin x square. Okay. Treat this as an angle only, just like t. So cos t with respect to t you are differentiating, that will be turning into minus of sin t. Okay. So minus of sin of x square you will be writing this as. Okay. Is it clear? Try to differentiate this function. Fx is equal to x power x. Is there a direct formula for this? A power x was there, but a in that case was a constant. Here x is also variable and the power is also variable. Done. What is the answer? X power x into log x plus 1. Okay. If I take log both sides, what do I get? Y is equal to x power x, you can read it as. Okay. If I take log both sides, what do I get here? Log y is equal to, again, log with base e I am taking. This is going to be x log of x. Okay. Property of log we are going to, okay, property of log is not known to you. Fine. A to the power of b is given. Let's say y is equal to a to the power b is given to you. When you take log both sides, b log of a you will be writing. Whatever power is there, that will come out, and the remaining thing will be inside the argument of log. Okay. For now, this is the property that you have to make use of. Just remember that. Now, after this, what are we supposed to do here? If we differentiate both sides now, tell me, what will be the value of this? Log of y with respect to x. If I differentiate this function, log of y with respect to x, what's the derivative of this? Tell me. Can you differentiate y with respect to x directly? Y is a function of x, no? Y is a function of x. Or in short, you can say log y is a function of y, and then y is a function of x, isn't it? Log y is a function of y, and then y is a function of x. So what kind of a differentiation, which rule you are going to use here? Chain rule, right? Can we write this as d of log of y? First with respect to y will be differentiating it, and then y with respect to x will be differentiating. Okay. What's the value of this? Log of x with respect to x was 1 by x, isn't it? Can we write this as 1 by y dy by dx, left hand side? So your left hand side turns into this. Now what about right hand side? Product rule you can make use of and find out the derivative of this. uv, u into v. What's the value of this? You can leave out x, differentiate log x. Log x derivative is how much? 1 by? What was the derivative of log x? 1 by x. Then leave out this log x and differentiate x. You will be getting this as log of x. So the final result for this is 1 plus log of x. Okay. Left hand side, what was that? 1 by y dy by dx. 1 by y dy by dx. So what's the value of dy by dx in that case? Y you can take to the other side, substitute in that in the form of x and get the final result. Take it down. Y was given to you. Why did I take log in this case? Because that is the way to eliminate the power, because variable power variable is given to you. So after taking log, this left hand side actually turns into a function of y. It's not no longer a function of x anymore. That's why first we have to differentiate that in terms of x. Then that function has to be, first we have to differentiate log y in terms of y, and then y has to be differentiated with respect to x, because originally y is a function of x. Log y is a function of y. Write down a question. Air was being pumped into a balloon. Air was being pumped into a balloon. At a rate of 10 centimeter cube per second. At a rate of 10 centimeter cube per second. Determine the rate at which the radius of balloon was changing. The rate at which the radius of balloon was changing when its radius was 10 centimeter. When its radius was 10 centimeter. Considering balloon as spherical body. When its radius was 10 centimeter. If you are used to differentiation, you will not find it difficult. If you are getting overwhelmed with the formulas and all those things, you need to practice a little bit. You have already seen the rules, what you have to follow. There are multiple examples that are given in your books. You just go through the examples, try to solve those questions first, and eventually you will get a hands-on on it. Okay, there's nothing to be overwhelmed about. You just need to understand what the basic meaning of differentiation and all. In questions, you simply have to make use of the formulas and get to the result. Okay, so try to practice all the questions that are there in your book, and you will be comfortable with this. Okay, by the next class. Now rate of change I have already told you. What is the meaning of dx by dt? Rate of change in x, isn't it? So try to decipher the language in that way and arrive at the result. The rate at which the air is being pumped into the balloon is given to you. What is the unit of that quantity? Centimeter cube per second. From there, what do you understand? Centimeter cube is the unit of what? Volume. So volume per second. What volume of air is being pumped into the balloon per second? That is given to you. Okay. And what they are asking you? Rate of change in radius of the balloon. So rate of change in volume, how will you write it? Tell me. dV by dt, isn't it? What is dV by dt? How will you read it in terms of rate of change? Tell me. Rate of change in volume, isn't it? Or if you want to make use of the complete sentence, that's also not going to hamper anything. We can simply say that this is rate of change in volume of the balloon with respect to time. Okay. So rate of change in volume with respect to time, how much it is given? 10 centimeter cube per second, right? Every second by this amount, I can say that the volume is changing, isn't it? So dV by dt is known to you, 10 centimeter cube per second. Now what exactly they're asking you? Rate of change in radius of the balloon. Okay. So do you know the expression for volume of a sphere? What was the volume of sphere? Tell me. 4 by 3 pi r cube. So can we write this as d dt of 4 by 3 pi r cube? This is equal to how much? 10. This is given to us. Okay. Now 4 by 3 pi, what is this? Tell me. Isn't this a constant? We can take it outside the differentiation. So by that logic, we are getting 4 by 3 pi d of r cube by dt. Now can you directly differentiate r cube with respect to time? R cube, x cube you can differentiate with respect to x, no? Similarly, r cube can be differentiated with respect to r first, and then r can be differentiated with respect to time because radius is changing as a function of time, isn't it? Radius is a dependent parameter on time because since the volume of air is being pumped into it, that's the reason why radius will keep on changing with time. Okay, so I can say r is a function of t, r cube is actually a function of r. Okay, so can we write it this way using chain rule? 4 by 3 pi dr cube divided by dr multiplied by dr by dt. Same thing, no? Multiplying and dividing with dr. This quantity is already known to us. How much is the value? Tell me. 4 by 3 pi 3r square, isn't it? Into dr by dt. This is equal to 10. R I have already given you. At the moment when radius was 10 centimeter, you have to find out rate of change in radius. Okay. So this R is 10 centimeter. So using that, can we get the value as 400 pi into dr by dt? This is equal to 10. So now this 400 pi can be divided over here. We are getting dr by dt as 1 by 40 pi. What's the unit of this? Tell me. Centimeter per second. Okay. Because this quantity is centimeter square. And this side we have centimeter cube per second. So when you are dividing, centimeter square will get cancelled out. You'll be getting centimeter per second. So 1 by 40 pi centimeter per second is the rate of increment in radius. Clear? So whenever you see a rate of a quantity is given to you, you can relate it with differential, okay, in the problems. Try to get a little bit of hands-on in case if you are not familiar with this concept. Question number 41 to 64. All those questions actually you can try out. Question number 41 to 64. Try to memorize all those formulas because that will be used while we start our discussion from kinematics. 41 to 64, page number 22. Page number 25, question number 2. Question number 3. Question number 4 also you can do. Two, three, four. 6. 2, 3, 4, 6. Challengers.